Hello, my name is Francis Koulibaly, and the next topic is scientific notation. Scientific notation allows us to express very large or very small numbers in more manageable form. This is important in healthcare, where you'll encounter measurements across many scales. So the equation of scientific notation is a times 10 to the n power. A is any number between 1 and 10, really 1 and 9, because the number cannot be larger than 10. And n is the number of places the decimal has moved, and can be positive or negative. Positive n means that the decimal moves to the left. Negative n means the decimal moves to the right. Now let's look at some examples. For our first number, we have many zeros, 0.00000025. So to write this in scientific notation, we have to make this number a number between 1 and 10. Right now it's below 10, so we have to move the decimal place until this becomes a number between 1 and 10, really 1 and 9. So we're going to count the places. 1, 2, 3, 4, 5, 6, 7. Okay, so our decimal will go right here, which means this becomes 2.5 because this is a number between 1 and 10, 1 and 9. So you have 2.5 times 10, and then our n number, we moved the decimal 7 times to get 2.5. So that means, and it's a number, it's moving to the right. So that means this is a negative exponent of 7 because we moved it 7 times to the right. So 2.5 to the negative 7. For our next example, we have 420,000. And to rewrite this in scientific notation, we need to first find a number, get this number to be between 1 and 9. So first, we look at where the decimal place is, which is here. We can't write this in scientific notation. This is too big of a number. So you have to move the decimal. We're going to move it 1, 2, 3, 4, 5 places. And this becomes 4.2, which is a number between 1 and 9. So 4.2 times 10. And then for our power, we moved it 5 times to the left. to the left. So this becomes 4.2 times 10 to the 5th, positive 5th, because we moved it to the left instead of to the right like we did in this one. Okay, for our final example, we have 1,250,000,000, and we need a number between 1 and 10. So we move the decimal, which is here, 1, 2, 3, 4, 5, 6, 7, 8, 9 places. So this becomes 1.25 times 10 to the 9th. The next topic is calculating density. So density is defined as the mass divided by the volume, which is this equation here. The units used for density are grams per cubic centimeter and grams per millimeter. For our first example, a rock has a mass of 15.5 grams and a volume of 6.01 centimeters. What is the density of the rock? So we know that density is equal to mass divided by volume. So we just input our numbers into the equation to solve. So this is 15.5 divided by 6.01, and putting that in the calculator, this becomes 2.58 grams per cubic centimeter. Okay, this is example problem number 2. An object has a density of 19.3 grams per cubic centimeter and a volume of 44.9 cubic centimeters. So we still use the same equation as the initial, density equals mass divided by volume, but now we have to rearrange it because we need to get the mass by itself. So we have 19.3 equals m divided by 44.9. And so to get the m by itself, we multiply by 44.9 on both sides. And that gets m by itself. And m is now 866.57, which rounded up becomes 867, and the units for this is grams. And for our third and final example, we have an object with a density of 0.785 grams per cubic centimeter and a mass of 50 grams. So again, we use the same initial equation. However, this equation, we have the density and the mass, but not the volume. This means when we plug these numbers in, equals 50 divided by v, and we need to get the v by itself. So this means we have to divide this number by 50 in order to get the v by itself. So that means v equals 63.7 centimeters cubed. Our next topic is calculating temperature. We have 3 different conversions of temperature: Fahrenheit, Celsius, and Kelvin. However, Fahrenheit cannot be converted directly to Kelvin, so Celsius is used, and vice versa, meaning Kelvin cannot be converted directly to Fahrenheit, which means Celsius is also used for that. So these are our equations. First, to convert Fahrenheit to Celsius, you would input your Fahrenheit temperature here, and that would be equal to 1.8 times Celsius plus 32. Next, converting Celsius to Kelvin, you would have Kelvin is equal to Celsius plus 273.15, or even just 273 is most often used. For our first example, we're going to convert Fahrenheit to Kelvin. So first, for our first example, we're going to convert 212 degrees Fahrenheit to its degrees in Kelvin. So first, what we do is we write our equation to convert Fahrenheit to Celsius first. So our degrees in Fahrenheit is equal to 1.8 times Celsius plus 32. So we have to get Celsius by itself in order to figure out what it is. So we first subtract 32 from both sides, and that gives us 180 equals 1.8 times Celsius. And then to get the C by itself, we have to divide by 1.8 on both sides. So our degrees in Celsius is 100 degrees Celsius. Now on to example number 2, we're going to be converting Celsius to Kelvin now. So our degrees from Fahrenheit is 212, and Celsius it is 100 degrees. So we're going to write our Kelvin equation so that we can convert Celsius to Kelvin now. So Kelvin is equal to Celsius plus 273. We know that our equivalent of this in Celsius is 100, so we just do 100 plus 273, and our degrees in Kelvin is 373 degrees Kelvin, and that is what 212 degrees Fahrenheit to Kelvin is 373 degrees Kelvin. Next up, we're going to be converting Kelvin to Fahrenheit, and we're going to be working backwards doing so. So our new equations is Kelvin minus 273 equals Celsius, and then we plug whatever Celsius is into our Fahrenheit equation, and Fahrenheit equals 1.8 times C plus 32 to give us Fahrenheit from Kelvin. Okay, for our third example, we're going to be converting 298 degrees Kelvin to Fahrenheit. So this means we need to equal 298 degrees Kelvin minus 273 to make our equation. This is the K, minus 273 equals C, which is equal to 25 degrees Celsius now. And that is our Celsius. Now that we know our Celsius, we can now convert Celsius to Fahrenheit. So this would be F equals 1.8 times 25 plus 32. And so this is equal to 45 plus 32, which is equal to 77 degrees Fahrenheit. And that is our answer. Okay, the next topic is converting metric system prefixes. So some examples of the prefixes, because there are a lot of them: tera, T, 10 to the 12th power, mega, M, 10 to the 6th power, centi, C, 10 to the negative 2 power, and nano, N, 10 to the negative 9th power. Any metric unit can be attached to any prefix which gives the unit a specific numeric value. For example, nanometer becomes nm, which is 10 to the negative 9th meters, or 0.000000001 meters. For a more specific example, we have 2.6 megagrams, which is 2.6 mg, or 2.6 times 6 to the 10th grams, or 2,600,000 grams. This can also be seen in mathematically converting from one prefix to another. For example, this is our first example. How many decagrams are in 2.6 kilograms? For metric prefix conversions, the first thing you do is write the amount and the unit given. The second thing you do is multiply by a fraction with the given unit on the bottom, the 1-2 unit on top. The larger unit gets 1. The smaller unit, you subtract the exponents, and the result of this is the exponent for the smaller unit. So for our first example, we have 2.6 kilograms, and we need to get to decagrams. So we put the larger unit on top, which is decagrams, and the smaller unit on the bottom, which is kilograms. Tripping. I'm tripping. So for our first example, we have 2.6 kilograms, and we're trying to convert it to decagrams. So we put decagrams at the top and kilograms at the bottom, and that equals 26,000 decagrams. Then we're trying to convert centimeters to nanometers. So we put centimeters at the top of the conversion and nanometers at the bottom, since centimeters is larger than nanometers. And that is equal to 1.82 times 10 to the negative 6 centimeters. And then for our third one, we're trying to convert centimeters to meters, and meters is the larger one, so we put it on top. So 5 divided by 100 is 0.05 meters. Our next subject is unit conversion, dimensional analysis, which is equal to factor, labor method, which is equal to unit factor method, is all unit conversion. This is our first example. 4.9, let me read it out. A weightlifter can lift 495 pounds. How many kilograms is that? So our conversion factor is 1 kilogram is equal to 202.2 pounds. So we have 495 pounds. We put pounds on the bottom because we want to get to kilograms. So we cross out the pounds, and we put 495 on the top, divided by 2.2, gives us 225. For our second example, we're trying to convert kilograms to tons. So a car weighs 1,920 kilograms. How many tons is that? So first we have to convert to pounds, and then from pounds to tons. So 1,920 to 1,920 kilograms times 2.2 pounds gives us 4,224 pounds. and then we put 4,224 pounds over 2,000 pounds, and that gives us 2.11 tons. For this next one, if 1 pound equals 16 ounces, how many pounds are in 435 ounces? So we cancel out ounces. 435 goes on top of 16. We divide them, and we get 27 and 3/6 pounds. The final topic is significant figures, and for significant figures, there are 5 key rules covered. Number 1, non-zero digits are always significant. Example, 1,234 has 4 sig figs. Number 2, zeros between non-zero digits are always significant. For example, 102,305 has 6 sig figs. Number 3, leading zeros before non-zero digits are not significant. 0.0045 has 2 sig figs. Trailing zeros in a number with a decimal are significant. For example, 43.00 has 4 significant figures. And lastly, zeros and coefficients in scientific notation are significant. For example, 8.0 times 10 to the third and 7.0 have 2 sig figs. Okay, adding and subtracting significant figures. You round to the least number of decimal places. For example, 2.34 plus 5,004 plus 481.44. And this is the number you originally get, but because 5,004 has the least amount of decimal places, you round to it has 0 decimal places, which means you round to 4 significant figures and 0 decimal places. The final rule for significant figures is multiplying and dividing. Round the result to the fewest total significant figures present in any output. So, for example, 24.5 times 63.2751 is 1,550.23995. And because there are 3 significant figures present, that's the least amount. Then we round to 3 significant figures, which is 1,550. And the importance of proper rounding is only round the final answer, keep extra digits in intermediate steps to avoid cumulative rounding errors.